Welcome back, my students. Today, this lesson, variation to the third prep. Variation divides into two types. Number one, direct variation. Number two, inverse variation. Direct variation, y varies with x. But inverse variation, y varies 1 over x. Direct variation, it means the two variables x and y increase together or decrease together. But inverse variation, it means the two variables x and y, if y increase, then x decrease. If x increase, then y decrease. Okay? Now, how can we solve the exercise on variation? We have two rules. Number one, y equals mx. But in the inverse variation, y equals m over x. The second rule, y1 over y2 equals x1 over x2. But in the inverse variation, y1 over y2 equals x2 over x1. Pay attention, in the inverse variation, y1 opposite to x2 and y2 opposite to x1. Okay? But in the direct, y1 opposite to x1 and y2 opposite to x2. In the direct variation, the constant m equals y over x. But in the inverse, m equals y multiplied by x. In the direct variation, the constant equal division of the two variables, but in the inverse variation, the constant equal multiplied by the two variables. Last, we have a graph represent this direct variation in a straight line passing through the origin point 0 and 0, or by this method in a straight line passing through the origin point 0 and 0 represent this direct variation. Okay, now let's go to the examples. The first example, if y varies directly with x, y equals 14 as x equals 42. Number one, find the relation between x and y. Number two, find y as x equals 60. First, we must start this relation, y varies with x. Now we have direct variation. Then we can write y equals mx. M is a constant. Then we use the first two numbers, y equals 14 and x equals 42, to find the value of this constant m. Then y equals 14 equals m multiplied by x, 42. Now we can find the value of m equals 42. 14 divided by 42 equals 1 over 3. Okay? If we write this value of m in this relation, y equals 1 over 3 x. Now we found the relation between x and y, the first required. The second required, find y as x equals 60. Second, in this relation, y equals 1 over 3x, put x equals 60, then y equals 1 over 3 times 60 equals 20. Now we have finished the first example. The second example, x power 2, y power 2 minus 6xy plus 9 equals 0. Prove that y varies inversely with x. Now, if we have this expression, we must factorize this expression into two brackets, factorize trinomial or perfect square. X power 2, y power 2 minus 6xy plus 9 equals 0. we can factorize this expression to xy, 9 became 3, and the middle sign negative. Now we have the same brackets, xy minus 3. We can write xy minus 3 power 2 equals 0 because the expression is perfect square. We can take xy minus 3 equals 0. Therefore, xy equals 3. It means y equals 3 over x. This y equals m over x. The constant here is 3. Therefore, y varies inversely with x. Now we have proved y varies inversely with x. Okay. Last example, we have in this example 3 variables: x, y, a, and x. Okay. A varies inversely with x. Then a varies inversely with x. Therefore, a equals m of x. Okay. He said a equals 5 and x equals 2. Then we can find a constant m equals a multiplied by x equal 5 multiplied by 2 equals 10. Then m equals 10, we can write a equals 10 over x. Now we have found the value of the constant m, but he say find the relation between x and y. Then we must use the first relation to find y. In this case, a equals y minus 2. A equals y minus 2. Then here we can replace a by y minus 2. Y minus 2 equals 10 over x, or y equals 10 over x plus 2. The relation between x and y equals 10 over x plus 2. Last, find y as x equals 1. We can replace x by 1, then find y equals 10 divided by 1 plus 2 equals 12. Okay, now we have finished the lesson of variation. With me in the next videos, and bye bye.